using sets and matrices. So what I'm going to do is when you see the homework, it's going to be I'm going to rename it actually, the one that I posted today, to 4.51 and 4.52. I'm just going to break up the homework into two so that tomorrow's will be posted. It should be relatively easy. Basically, we're doing the same thing over again. Where today is focused on using sets in the homework assignments, vertice edge notations, and then tomorrow will be to describe using matrices. There's not too much to go, you know, elaborate things to go about doing it. If you feel comfortable doing what we've already done so far, today should feel relatively easy. Of course, there could be some little couple of tricky parts, but like again, if you've gotten what we've done, it's just a building off of that, and it's not that bad. So in directed graphs, directed network graphs can be one-way directed. They can also flow both ways and are noted with two arrows as such. So we talked about a network such as this, and these are the vertices. And of course, when we did our previous ones, we just drew them like something like this. And that was our network. A talks to C, A and C talk to each other, A and D talk to each other, A and B talk to each other, and B and E talk to each other. But now we're going to talk about A can only, so in terms of this network, C can only talk to A, where A does not send information back to C. So, it's a one-way communication here. B can talk to E, so E does not have anybody to talk to. Well, because they're at the end, though, they need to have some type of communication. We can, these networks do not have to have straight lines, just to let you know. They can curve. It's more than happy. So B talks to E and E talks to B. A talks to B. And both of them talk to D. So with an arrow, so this is an example of a this is right here an example of a network graph that's directed. Okay. And for the edges, edge notations always list from start to end of direction. Basically, what we're saying here is that when we have something that's like this, we typically call this I and J, Okay, and so we always list it as I and then J, and it should be note that we use parentheses, not braces, for a directed graph. So we talk about it as I and J, where I is the start of the network and J is the ending. So it always flows from I to J. Questions? So we'll do an example. Let's describe the network, and it's directed, so it's already known, the network graph above. Using set notation. Well, so what do I do on this using sets? How do I describe it?
Oh, you're right. J is connected
There's no J's in the network.
So what's that? Point. I think we're taking.
That wasn't an yeah. The IJ was just part of the notation and the notes part. The example we're doing is the A B C D E one.
So C has a direct connection to A.
No. I'm asking how do we describe it? What do I write down to describe it using our set notations? Just from like we did yesterday or last week.
Oh, so it would be like CA.
We're not there yet. No, you're missing a lot of notations. We have to identify what we're talking about. And the first thing we identify and talk about is what when describing a network.
A, C, D, B, E.
Okay. What are those? How do I write that?
In between brackets, A.
No.
C. Mister, don't you gotta name the vertex?
Yes, the vertex. So V and I got to name the vertex or the vertices, more multiple. And as Eliana is trying to tell us, it's A, B, C, D, N, E. You must tell me all of the vertices that are being used within the problem. So what are all our nodes? Where are all our destinations? You have to identify all of them. Now, there are such things as we will get into. There's such things as isolated. There's sometimes vertices that don't talk to anybody, but they're still part of our network. We got those people who are just, that exist but don't talk to anybody. Then no one talks to them. So in that case, if you just listed the edges, they would not be included. So we really want to make sure we have all our communication flows in terms of where they can flow to and from inside or apart. Now, what do I describe?
The edges.
The edges. All right. And the edges are
CA.
Okay, and we use a parentheses, so CA. And for our purposes, we use parentheses. If you just wrote CA in some notations, if you just wrote this, and we're not going to do it for ours, but if you might look somewhere else, and you might see it like this, and that's appropriate as well. Well, I want us to kind of keep the same type of notation. This is also valid notation here, so that we always write each edge as its own little piece. So CA.
AB.
AB.
AV.
AD.
And DE.
BE.
BD.
BD.
A, B, B, D, B, E. That's all.
No, it's not.
Yeah, those are all. A, B, BD, BD, BE.
Anybody help?
Oh, well, you also have to like.
Can you explain like what you're trying to do again?
We're listing all the edges. We're listing all of the network flows, all of the edges.
A, B, C, D, E.
No, that would edges are only 2.
Oh, sure. So C, A.
We got all those written down. We're trying to finish the problem.
EB.
There it is. EB. So you got to be careful in that BE and EB are 2 different directed flows. All right, so you must state them both. B communicates to E and E communicates back to B. So it is a flow of going back and forward. So you must state both BE as an edge and EB as an edge as well. And that's the answer. That is the whole. That is the answer. That's everything right there. There's nothing more that I'm asking you to do. We label when we are asked to describe using set notations. We use both. We must first state the vertices, all of our nodes that are in our network graph, and then we must state the edges. And then for a directed one, we always have to list. We have to list all of them that go from the start to the finish. So this one's a little bit more. You have to be a little bit more present to detail here. But we can also count 1, 2, 3, 4, 5, 6. There's 6 flows, as we call them sometimes. And so we must have 6 as well. 1, 2, 3, 4, 5, and 6. Listing all of them from the start to the end direction. Let's try another one. Okay. Describe the network graph using set notation. So we want to double check in here, and I got 1, 2, 3, 4, 5, another 6. There's 6 total network flows. So we must make sure that when we describe it, I'm going to have 6 different answers for my edges in terms of my edge pieces and descriptions.
So the set notation would be 1, 2, 3, and 0.
So the vertices,
Vertices.
0, 1, 2, and 3. Just listing them. Just listing my destination, just listing my vertices.
and edges, which I think I got the right answer in my mind.
All right. Well, let's hold on before you start saying them out loud. I want people to be able to take a look at it. I want to give at least a minute for students to be able to look, process, and attempt to write them on their own, and then I'll take responses out loud. So please try to write these down. The edges is the more important thing. That is more practice that you need right now. Of course, writing the vertices is just literally something that you just need to remember. It's a practice. In terms of, like, if you're not doing the homework consistently, you're waiting to do the homeworks, you're not doing the homeworks at all or practicing, you're just kind of like here at all. Remembering that you have to list the vertices is typically a very good indication just that you're not keeping up to date and practicing. Because it's literally just something that you have to just, okay, every single time you do this, you do this. So I'll give you a chance to write them down. This is something down. You can write them to me in terms of a direct message or practice. Use this time real quick to try. So who wants to say them out loud? Remember, Brianna, they are directed, they are directed ones here.
I want to.
All right, what do we got?
So we got parentheses 1, 2.
No.
2, 1.
2, 1.
Parentheses 3, 0.
We got 3, 0.
We got 1, 3.
We have 1, 3.
1, 0.
1, 0.
0, 2.
0, 2.
And 0, 1.
0, 1. Let me just bring this a little bit over. Keep doing that. 0, 1. So these, since being that these are directed, you must list each of the direction flows from start to finish. If this was undirected, then we would have labeled them as each of these as braces within the edges, noting that it just goes in both directions and that there is no direction of one talking to the other. There's also two. Everything is just a two-way flow. That's when we use the braces and list all of the connections. In that one, and that in that case, there would have been 1, 2, 3, 4, 5 of them if there was none. If it was an undirected. So the difference between directed and undirected is that. Okay. If you can do this, the next piece should be relatively straightforward, and that's describing networks. And networks and graphs, network graphs all mean the same thing using matrices. Basically, this is the same as undirected, except must note only I, J direction flows. When we have a network, or when we have, a matrix, these values here are referred to as the I's, and these here are referred to as the J's. So when we do it, we really only, and here's the nice thing about this. Basically, you need to only always start the the start of flow is there. So these are much easier. You don't have to, and then this is actually easier than the undirected ones because you don't have to worry about symmetry. You only have to look about, we start from the left and we go to the right. And also, just as a reminder, we're always going to have those zeros that are going to go left, diagonally and so forth. Oh. Can you still hear me? So, sorry for the disruption of the internet service. I was saying, so we start from we always label from the I, which is the start of the flow. So basically, you always look from the number on the up and down part on the left, from the rows, and then you match it to its endpoint, which is really nice. So of course, since none of them are talking to themselves in these direction flows that we are working with, we have zeros along the diagonals. Let me take a screenshot of this part right here because we're going to do the same ones. So let's do an example. And this is the first one. So we're going to describe the network using matrices. So that is our example right there. And just kind of like just with the vertices, or just with like set notation, the first thing we have to do is, draw our matrix and label the what? What is the first thing we need to identify in my solution, in my description?
The vertices.
The vertices. So I also know that there's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3,
Distributor 6.
4. What?
Those are 6.
There are 5 lines that I drew. If you
Yeah,
recall,
those are 6
yes,
boxes.
exactly. And if you recall from my previous lecture, I said that this was the trick, that if there's 5 vertices, you're going to draw 5 lines because you need that extra one. You need that n+1 rows and n+1 columns.
Do you need a endpoint?
So I had stated that you always draw that amount of lines because you need that extra one. So yes, there is 6 boxes going up and down and 6 boxes going left to right. But that is purposeful because we have to label the vertices. So my vertices are A, B, and remember I said we do not write the one right here, C, D, and E, A, B, C, D, and E. Give everybody the time to write that down. Draw their box. Since there is 5 vertices, we're going to draw 5 lines in between our table because we need, and that will create the extra row and the extra column so that we can label in the vertices. Give you the time to write that down. Now, what is the first thing I probably should identify on my matrix?
The zeros.
Yeah, because there's none of these nodes are talking to themselves, so I label my zeros. Now, we always start, remember, by identifying the number here. So basically, when you read it, you want to read it from here, like, does it go here to here, here to here, here to here, in here, or here to here? Now, I'm going to draw these. What's my first one that I'm going to see?
CA.
CA. So I find C here, and I go from C to A. So that's the C to A one. And so I'm going to label that with A. I'm going to write, what am I going to write in that box? What is that?
A1.
A 1.
And then zeroing all the others.
No.
Yeah, zero.
No.
Because C
No.
doesn't.
No. Oh, I get what you're saying there. I get what you're saying. So when you have to be specific, if you said in all of the others, isn't that all the others?
Okay. In all the others in column C.
Very good. So what Eliana is saying in here is that C talks to A, and then C does not talk to anybody else. So the other ones, C to B is 0, C to D is 0. So once you talked about one of them within the row, you're going to go row by row in regards to how you do these ones. And that is, in fact, the best way. Next one.
AB.
A, B. So A, B is my next network flow. So I'm going to put a 1 there. And does A talk to anywhere else?
D.
What is that?
D.
D. A does talk to D. And does A talk to anybody else?
Nope.
No. So then 0 and 0. And when we did undirected ones, I found them to be more difficult because we had to go A, C, and then we had to locate C, A as well. So it was like, I mean, some people you can do this attack this one the same way as the other ones, but then you have to do A and C and C and A, and you could go by row by row. All right, let's go B. Does B talk to anybody?
Text to D.
D. Okay, so B, D right here talks to B, flows to D, and B flows to
E.
E. Okay, and those are the only two that B talks to. B flows to D, and B flows to E. So zeros on my other one. Does D talk to anybody?
No.
No. So D does not talk to anybody. D, everything flows to, there's multiple things that flow to D, but D does not communicate anything back to anybody else. So D has all zeros in there because D is not talking to anybody directly. And finally, E.
Just communicates to B.
To B. So I put a 1 for E communicating to B, and that's all it communicates to. So zeros and zeros. That's the answer. And of course, the record button was not hit from that last part after I stopped. So I'm just going to repeat kind of what we did on this previous example because it's just so that it shows up in the recording. I'm going to repeat the same thing that I just did, that we just talked about, but slowly, so that we have it within the notes. I apologize. So I'm just repeating. So what we had talked about here was that C had talked to A. So C goes to A, but C does not talk to anybody else. So we can fill in the row that C does not direct to anybody. A talked to B, so we put a 1 on A to B, and A talked to D, so there's a 1 and a 1 right there. Zeros in the other directions. B talked to D, and B talks to E. Zeros in other places. All the information flows to D, but D does not talk back and communicate to anybody else, so D has all zeros in its row. And finally, E communicated back to B, so we have a 1 for E to B and zeros on the other places. All right. Yep.
I'm confused on that whole roundabout situation going on.
About what?
The roundabout situation, the loops, the circles, the
Those
arrows going up.
the arrows, the circles. You got to be more You got to be more clear.
It's right there, Mister. The arrow. See how you put two arrows going in a circle, like going around, next in between the O and the I on the B part.
0 to 1. It doesn't matter that they're curved. I can curve every single one of them. It just says that 0 is talking to 1 and 1 is talking to 0. It's the same example as this one right up here, as the BE situation. It's the same exact thing as this. So 0 is communicating to 1 and 1 is communicating to 0. It's a two-way street, as we can say. So you can drive from B to E and you can drive from E to B as well. E is what we so there are no D is like a dead end. If you think of these as streets, D would be an example of like a dead end street. You can go into the street and then you can't come out of it. It doesn't there's no way out. You just go in and then you're stuck there forever. I guess that's not like a two-way street, but there's still certain information holes that you can get to that, that's the end of the line. You got to get off. So you're on a train. You can think of it as the MBTA. Two bus lines, like it could be like Dudley Square, right? You can take the one bus, and it'll get you to Dudley Square, and there's another bus that also gets you to Dudley Square, but that's the end of the line, and therefore you are done. All right. Um, Everybody has to get off, but then you have like E, and this one just goes in circles. It never really ends service for E and B. So E, it goes to E, but you can stay on, and it'll go back. It'll take you back to B. All right. So once the bus gets to D, it goes out of service. All right. That train is now out of service, and so you have to stay off. So you have to get off at D, no matter what. Mostly that happens like on the especially like you're going to taking the MBT, the subway, right? You go to D and then it's end of the line, you get off. You can't just hang back around. Whereas over on E, you get there and, well, it's not the end. There is no real technical end of the line because this bus just keeps going around and around and around from one spot to the next and going back and forth and back and forth. You can think of B and E as being more like a shuttle service that just keeps going on and on and on, back and forth. And if you wanted to, you can just keep riding the shuttle and it'll just take you in circles. So hopefully that example clears that up. All it is, it doesn't matter. I could have easily have just drawn these. Some people will note them as this. I find that to be harder to distinguish in here. That is technically an appropriate way. You could draw them like that. Some people will draw one of them always as straight and then just another one as a curved. That's also perfectly fine. It just kind of like how do I be able to identify in the diagram the easiest way? And so the way I just done it and just saying we're just going to go from here to here, just curve both of them so that we don't signify one is better or different than the other. That's it. So let's give an answer. What do I do?
We're gonna do the square as the other problem.
And I have
right or
we have four vertices. 5. We have four vertices. So we're going to draw 4 lines drawn. 1, 2, 3, and 4. And same thing, going to rows 1, 2, 3, and 4 lines. We will label our vertices now. 0. And I'm gonna note this 0 as like a line that goes through just so that I can signify the difference between 0 and a 0?
Zero and a zero.
2, 3, 0, 1, oops, 1, 2, and 3. So the numbers on the outside represent each of the vertices. Now we label the vertices all in the rows. We label them in the rows. Row 1, here's the first row, second row, third row, and fourth row, because those are where the start, the butt of the flow begins. All right, so what do I have?
So we first put the zeros.
Good. Now, like I said, there are situations, and I'm not really going to cover it because there's, there are situations of something that flows back to itself. We're not going to really cover that. There are situations with that, but it's not something that we're going to do because we're trying to talk about the application of information flowing. But there are self loops that do occur, but none of those are occurring in any of our problems. But it can. I just want to know that. All right, so now what?
So for the first column, 0. You put
row.
You put a 1.
Row.
You put 1 and 2.
So 0, 1 and 0, 2. 0 talks to 1 right there. And 0 talks to 2 right there. And I've noted those in my matrix. I'm just gonna, we can also just put a 0 now in the next one because 0 does not talk to 3. All right, let's go to our next row. 1. What does 1 talk to?
It talks to 0 and it talks to 3.
Talks to 0 and talks to 3. And does not talk to 2. All right. What about 2?
It just only talks to 1.
2 talks to 1. And talks to nobody else. Good. And finally,
3 just talks to 0.
3 talks to 0 right there. And doesn't talk to the other 2. That's it. Now, in regards to how to set up your homework, tonight's homework, which if hopefully you'll be able to, if it can't access Google Classroom right now, you'll be able to access it. It'll be back up. Is just using sets. So you're labeling the vertices, and I actually give you the first part where I say V equals brace, and then E equals brace, and you got to make sure you're talking about you're using direction, so there should be no braces inside when you talk about the edges. They should be with parentheses. In tomorrow's homework, basically it's going to be the same problems. The same network graphs. There's 5 network graphs from tonight, and it's going to be the same 5 network graphs tomorrow, and you're going to describe them using the matrices. So, for example, we did, the first 2 examples that we did is part of tonight's homework, and the last 2 examples that we did is part of tomorrow's homework. That should help with the asynchronous time that you have. That's everything I have from you for today. And like I said, I'm going to label this as 4.51 for tonight's homework and then 4.52 for tomorrow's homework. If you have extra questions, stay around. If not, you are free to go.